All right, let's do number 11. This is 8.4a, practicing conditional proofs on page 394. We got a couple premises, and our conclusion is a conditional. Notice that's the main operator, the arrow. So a good strategy will be to do conditional proof. The idea, our strategy is going to be, we'll assume the left side, sorry, that's an H. We'll assume the left side of that conditional statement in a pretend world, and we need the last line to be a J somehow. And then, according to the rules of conditional proof, we'll conclude first line inside the box, arrow, last line inside the box. And somehow in between, we'll have to get to J. So let's go ahead and do that. We'll assume not L or H inside a pretend world. I don't know how far this is going to go, but this will keep going down. Assume for conditional proof. And somewhere down here, we need to get J. That's our goal. How are we going to do that? Well, if you're not sure, you might look through your list of rules and you might see, so remember they're in the inside cover of your book. There are the implication rules, and which one might be useful here? Constructive dilemma, we have a disjunction, and then we have a premise that goes from the left side of the disjunct, line 2, to something else, and we have a premise that goes from the right side of the disjunct to something else. So it looks like we could use constructive dilemma. Let's go ahead and try that. If we do that, we're going to be using line 3, 2, and 1, constructive dilemma, and on the left side of the disjunction, we're going to get J and M, and on the right side, we're going to get J and K. Awesome. Now, a reminder that our goal is to get J at the bottom of this box. And when you look through your rules, you might notice that this line 4 resembles something in distribution. Look at it, the right side of this version of distribution. You have a disjunction and an and on each side. That's what we have. And you have a P and a P. We have a J and a J. So we'd use distribution to get something like this. So that's going to give us J and M or K. So that's line 4, distribution. We're still trying to get J at the bottom. Now we have a conjunction, and with a conjunction, of course, we can just simplify and pull out one side or the other. So we'll pull out J. So that's 5 simplification. That's what we are trying to get, which allows us to write this conditional by the rules of conditional proof. So we end our pretend world. In our pretend world, we pretended that line 3 was the case. And with that assumption, that led us to J. So that means we know that if not L or H, if not L or H, then J. We don't know whether it's the case that not L or H, but we know if it were the case that not L or H, then J would follow. So that'll be 3 through 6 conditional proof. All right, awesome.